6 men and 6 women are to be seated at a round table. In how many different ways can they be seated if men and women alternate? So first of all, I just draw a table first. Okay, let's say there are 12 seats around the table. Because they're in a round circle, so there is no first or second place to be filled. So we can fix either a man or a woman in a particular seat. So let's say if I fix man here, this is man. So the next man either here, 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 or here. So therefore, this seat here, we can have 5 men to choose from because 1 man already been fixed. So now we have 4 to choose from in here, and then 3 to choose from, 2 men to choose from, and then only 1 man to choose from. So for men, we have 5 factorial. And then for women, so we have 6 women to choose from here, for this place here, so we have 6. And then we choose 1 already, we have 5 women to choose from, and then 4 women to choose from, and then 3, 2, 1. So for women, we have 6 factorial. So that is equal to 86,400. Or we can do exactly the same process as arrange in a row. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's say men here, and here, and here, 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 and here. So for this place here, we have 6 men to choose from, and then 5 men left, and then 4 men to choose from, 3, 2, and then the last man. And then for women, we can have 6 to choose from, 5 to choose from, 4, 3, 2, 1 as well. So that is 6 factorial for women and 6 factorial for men as well. So remember, for a circle, we have n factorial over n, or n minus 1 factorial. 6 factorial times 6 factorial, I'm just using this rule here. So that is divided by 6. So that is equal to, this cancel with that, leave with 5. So same as 5 factorial times 6 factorial, which is also equal 86,400. In how many ways can 6 people from a group of 15 people be chosen and then arranged in a circle? So first of all, we do combination first. So we have a group of 15 people, and we only want 6 people from the 15 people. So we just go 15, choose 6. That is the combination. If you would like to learn more about combinations, please click on the link on the description below. So now we do the arrange in a circle. So arrange in a circle, so we know that n factorial over n. So that is, we have 6 people to arrange in a circle. So that is 6 factorial over 6. So that is 5 factorial if you like. So now we just time them together. So which is 15, choose 6, which is 15c6 if you like, times by 5 factorial equal to, so just put this on a calculator. So I just go 15c6 and I times by 5 factorial. So which is 600,000 and 600. So just write this down, 600,000 and 600. A family of 8 is seated randomly around a circular table. What is the probability that the 2 youngest members of the family sit together? So if you think you can do this question, so please stop the video and try it yourself. Otherwise, just watch how I do it. So I use the same process as arrange in a row. So a family of 8. So which is 1, 2, 3, 4, 5, 6, 7, 8. And the 2 youngest members must be together. So let's say A and B must be together. So that means we tie these 2 together. So we have 6 people left for this. So A and B tied together as 1. So that is, we have 6 plus 1. So we have 7 factorial. And remember, A and B can switch around. So which is times by 2 factorials. So this is times by 2 factorial. But remember, arrange in a circle. So therefore, we divide by 7. Because n factorial over n, or n minus 1 factorial. So this is same as, so remember 7 factorial, it is same as 7 times 6 factorial. So I can cancel this, so left with 6 factorial. So that is 6 factorial times by 2 factorial. Now for no restrictions, so that is a factorial. So because a family of 8, so which is a factorial over 8, because it's arranged in a circle, which is 7 factorial. So therefore, the probability that the 2 youngest members sit together is equal to 6 factorial times 2 factorial over 7 factorial. So that is, so this is 6 factorial, cancel with this, leave with 7, because 7 factorial is just 7 times 6 factorial. So we cancel out. So that is 2 factorial is 2 anyway. So which is 2 over 7. Seven people are to be seated at a round table. How many sitting arrangements are possible? Part 2. 2 people, Kevin and Jill, refuse to sit next to each other. How many sitting arrangements are there possible? Please stop the video and try this one yourself. Part 1. So we know that there are 7 people altogether. So because you sit around the table, so all we need to do is just 7 factorial divided by 7, or 7 minus 1 factorial, so which is equal to 6 factorial. So put in a calculator, which give me 720. Part 2. We know that Kevin and Jill refuse to sit next to each other. So we do the restriction first. So the easiest way is we do Jill and Kevin sit together, and then we minus from the no restrictions. So let's say Jill and Kevin sit together. So that means 7 people. So we have 1, 2, 3, 4, 5, 6, 7. So Jill and Kevin together. So we have 1, 2, 3, 4, 5 left. So which is 5 people here. And then this, we tie them together, which is, let's say, Jill here and Kevin here. So this counts as 1 because we tied them together. So 1. So 1 plus 5 is 6. So which is, I just write here. So we have 6 factorial. And then because Jill and Kevin can switch around, so which is times by 2 factorial. So which is times by 2 factorial. And then because it's arranged in a circle, so we must divide by 6. So to simplify this, because 6 factorial is just 6 times 5 factorial. So this is cancelled with this 6. So leave with 5 factorial. So the answer is 5 factorial times 2 factorials. And now, not together is no restrictions minus together. So that is 6 factorial minus together, which is 5 factorials times 2 factorial. So if I put this in a calculator, which give me 480. Thank you so much for watching.